Hi, welcome to our channel. So today we will be solving a CSIR net problem on matrix. So this is a part B question. So therefore only one option is correct. So let us see what's the question. The square matrix A is defined as A is equal to, which is a 3 cross 3 matrix. The diagonal matrix D of A is. So we need to find the diagonal matrix D of the matrix A. Okay. So four options are given. Only one of them will be the correct option since it is a part B question. So these are the four options. So let us solve it. So first of all, we will consider the matrix A. So this is the matrix A. So now to find the eigenvalues, we will be using determinant of A minus lambda I is equal to 0. So therefore what is that? Determinant of 1 minus lambda, 2 minus 2, 1, 2 minus lambda, 1, minus 1, minus 1, 0 minus lambda, which gives minus lambda is equal to 0. So now solve for this determinant and find the eigenvalues. So this implies 1 minus lambda into 2 minus lambda into minus lambda, minus of minus 1 into 1, that gives plus 1, minus 2 into 1 into minus lambda, which is minus lambda, minus of minus 1 into 1, which is plus 1, then minus 2 into 1 into minus 1, which is minus 1, minus of minus 1 into 2 minus lambda, which becomes plus 2 minus lambda is equal to 0. So this implies 1 minus lambda into, so let us multiply them and solve it. So we get minus 2 lambda plus lambda square plus 1 minus 2, that is minus 2 into minus lambda plus 2 lambda minus 2. So here we have 2 minus 1, which becomes 1. So minus 2 into 1, which is minus 2. Then minus 2 into minus lambda, that is plus 2 lambda is equal to 0. So this implies, again multiply each term. So we will be getting minus 2 lambda plus lambda square plus 1 plus 2 lambda square minus lambda cube minus lambda plus 4 lambda, that is 2 lambda plus 2 lambda minus 2 minus 2 minus 4 is equal to 0. So this implies, so first we will write the cubic term minus lambda cube. Next we will write the square terms, 2 lambda square plus lambda square, that is 3 lambda square. Then let's write the lambda terms, minus 4 lambda plus 4 lambda minus lambda, which is 3 lambda minus 2 lambda, that is plus lambda, minus 4 plus 1 minus 3 is equal to 0. So this is the characteristic equation. So this is the characteristic polynomial or an equation which we have got. So now solve this characteristic equation to know the values of lambda. So by trial and error method, we will find the values of the first eigenvalue. So let me take, so first of all, how do we find that? We will be taking the coefficients of each lambda terms. So first of all, we will be taking the coefficient of lambda cube minus 1, then coefficient of lambda square 3, coefficient of lambda 1, and the constant term minus 3. Suppose by trial and error method, if I take lambda is equal to 1, whether it satisfies this characteristic equation. That is, if I take lambda is equal to 1 minus 1, substitute lambda is equal to 1 in this characteristic equation. So what do we get? Minus 1 plus 3 plus 1 minus 3. So minus 3 plus 1 minus 1. Yes, it satisfies. So let me bring down this equation to a quadratic equation so that I get the other two eigenvalues of lambda. So therefore I'll be using the synthetic division method. So when lambda is equal to 1, how do we do that? First we will be writing the 0 element here. Then minus 1 plus 0 is minus 1. Now 1 into minus 1, that is minus 1, write it here. Now 3 minus 1 is 2, write it here. Then again 1 into 2, it is 2, write it here. 1 plus 2 is 3. Then 1 into 3 is 3. Minus 3 plus 3 is 0. So when we get 0 here, it means that this lambda is equal to 1 satisfies the characteristic equation. Okay. So therefore, what is the quadratic equation which we get? So that will be minus lambda square, that is taking the coefficient of lambda square to be minus 1. Then take the coefficient of lambda to be 2, that is plus 2 lambda. Finally write the constant term which is 3. So now solve this equation by quadratic formula or by finding the roots. So how do we do that? Minus 1 into 3, that is minus 3, and this element 2. So what are the elements? So if I take 3 into minus 1. So 3 into minus 1 gives me minus 3. Yes. 3 minus 1 is 2. Yes, I am getting 2. So when you multiply those two elements, you have to get minus 3. When you add those two elements, you have to get 2. So such elements are 3 and minus 1. So therefore, what are the roots? Lambda is equal to lambda 2. Let me give it as lambda 2. And let this be lambda 1. Let this be lambda 1. So let me take lambda 2 as 3 and lambda 3 as minus 1. So what are the eigenvalues? Lambda 1 is equal to 1, lambda 2 is equal to 3, and lambda 3 is equal to minus 1. So I got 1, minus 1 and 3 as the eigenvalues. So these eigenvalues are real and distinct. Since it is a 3 cross 3 matrix, you have to have 3 eigenvalues. Since the characteristic polynomial is of order 3, you have 3 eigenvalues for a 3 cross 3 matrix, and all these eigenvalues are real and distinct. So therefore, they can be written in the diagonal entries of the matrix. So therefore, this satisfies the diagonal entries. So therefore, what has to be the diagonal matrix? So therefore, the diagonal matrix will have the eigenvalues. Okay. So I can write it as 1, minus 1 and 3, with all the remaining entries as zeros. So therefore, this is the diagonal matrix. Okay, this is the diagonal matrix. So once you get the eigenvalues, go and check in the options. But we need to be sure that the eigenvalues are real and distinct. Okay, if it is real and distinct, preferably it lies in the diagonal entries. So therefore, we can say that this is the diagonal matrix. If the eigenvalues are repeated, or if the eigenvalues are not real and distinct, then we need to find the eigenvectors and use the diagonalization method to find the diagonal matrix. Otherwise, if the eigenvalues are real and distinct, we can say that the eigenvalues are in the diagonal matrix, diagonal entries. So therefore, this is the diagonal matrix. So therefore, in our option, if we see 1, -1 and 3 as the eigenvalues which are on the diagonal, so option C is the correct answer. Okay, so therefore just find the eigenvalues and solve this problem. Thank you.